Hello everyone, in this part of the video today I'm going to look at set 3 factorization of quadratic expressions. So I'm going to work only a couple of examples from this worksheet itself and then we'll leave you to do the remaining of the practices. Okay, so for the first question, factorize the following questions completely. So we know that the first one we have our x squared term over here. We'll have draw a window frame method. This is the table method. X squared, let's decide what number times what to give you x squared. So we will have x times x to give you x squared. Next, we'll look at the number positive 15. We'll put that number over here. This is the number 15. Then we need to think of what number times what number gives you 15. So we know that the number 3 times 5 can give you 15. So you'll put those numbers over at this portion over here. So 3 times 5 can give you 15. Okay, but we have many different versions of answers, right? But what we want to do is we want to get 8x over here. So we know that 3 times 5, 3 and 5 can add up to give you a number 8. So firstly, let's take a look. X times 3. So this box here will be x times 3, 3x. Okay, x times 5. So this box here will be 5x. Let's take a look at our numbers. We want 3x over here. We are going to look at the terms over at this side. We have 3x and we have 5x. The question's objective that they want is 8x. So I must make sure I get 8x over here. What is the sign going to be? I need both of them to be positive. So that we add them together, it will give me 8x. So if that's the case, this is going to be a positive number. Now we have my sign over here. So my first bracket will be x plus 3. The second bracket will be x plus 5. So when they say factorize, we'll write it into two brackets. This will be x plus 3. The other one will be x plus 5. Okay, let's try one more question. Now, the one that we started off with is easy because there's all the positive sign over here. So let's take a look at another term which have a negative number, right? So firstly, in the first corner over here, we will have x times x to give me x squared. Okay. And the next number over here at this portion, this is negative 14. But I only write down the number 14 first. I'll put the sign later. Okay. Then I need to think what numbers times what number give me 14. So 2 times 7 can give me 14. Right? I also can have 1 times 14. Can give me 14. But I need to know that the numbers that I use, right, can somehow be related to the number 5. Okay, can add or subtract to give me a number 5. So in this case, 1 and 14, if I add or I subtract, I'll not get 5. Okay, but 2 and 7 minus 2 can give me the number 5. Right? So in this case, I'm going to use the number 2 and 7. So I'll take 2 times 7. Okay, and I will have this box here is x times 2. X times 2 to give me 2x. This box over here, this will be x times 7 to give me 7x. Okay, looking at this box over here, I want the total sum to be 5x. So 2x, 7x. I want the total number to be positive 5x. I can only add or subtract, right? So that means positive 7 subtract 2 will give me 5x. So I'll put the sign for 7, that is positive. 2 will be negative. And check the sign. This one over here, so it's plus and minus. Plus times minus, that will give you negative 14. So what are the two answers? We have the first bracket and the second bracket. This one will be x minus 2. The other one will be x plus 7. Have you gotten the answer? The next type of quadratic expressions, okay, that we're going to look at for factorization is this type where you notice that we have a square term and we have a number. Okay, but we do not have the x term in between. So in this case, usually I will tell my students to read it as a square plus 0a minus 9. I want to get a target of 0a, 0 units of a. Okay, so in this case, I'll just begin with my a square. So this is a square term, a times a to give me a square. I'll still go with my number over here. This is negative 9, so I'll look at the number 9. Now in this case, I want the numbers something times something to give you 9 that is the same number, such that add and subtract each other, they will become 0. So in this case, 9, and I want the same number, so that means I can only think of 3 times 3. So I'll take 3 times 3 to give me 9. Okay, and let's take a look. 8 times 3 will give me 3a. And this one over here, 3 times a will give me also 3a. Remember, I want the portion over here to become 0a, no a at all. So this will be 3a, 3a by 1, 0a. That means I will have 1 plus, the other one is minus, so that it becomes 0. So I can just randomly choose. One of them is plus, the other one is minus. So this one will be plus, this will be minus. Okay, and we get a negative 9. So if that's the case, the answer, we'll have 2 brackets over here. This will be a minus 3. The other one will be a plus 3. Have you gotten the concept? Let's try one more question. Part B, b squared minus 49. So in this case, I'll just put my b squared over here, b squared, and the number 49 over here. Okay, then I'll have b times b to give me b squared. Okay, and I want 49. I must think of something. Notice that there's no b term, so it's just b squared plus 0b minus the number 49. Okay, so then that's the question. We're going to look at 49. What times what can give me 49? So that will be 7 times 7. Okay, and my question over here, this will be times 7. That will be 7b. And then this one over here will be b times 7, also 7b. Right? And remember, I want these two to become 0. So this is 7b, but I want them to become 0b. No b at all, so 0b. That means one is plus, the other one is minus. So I just put 1 plus, 1 minus. And this will be negative 49. Okay, so then I will have my 2 brackets. This one will be b minus 7. The other one b plus 7. Okay, you can write it the other way around also. It's still correct, as long as you make sure you have 2 signs, 1 plus, 1 minus. Right? Now just sidetrack a little bit. Now for different versions of the questions, normally we will always have the letter in front. But what happens if I have the question 49 minus b squared? Does it work the same way? Oh yes, this case, the question will also work in the same way. But however, we will write this as 49 over here, and the negative b squared will be down here. Then we will take b times b to give you b squared. Okay, and the number 7 times 7 to give you 49. This will be 7b. This will be 7b. I want them to become 0b. Then this one will become 1 plus 0b, 1 plus, 1 minus. So I'll put one of them as plus, the other one as minus. Okay, and in this case, when I have the numbers like that, my answer for this kind of version will be 7 plus b, 7 minus b. So the method can work the same way, just that the number positions of the letters and the numbers can switch around, can swap, okay, position. So not very common, but still sometimes you might need to know. All right. Okay, then I'll go on to the last type of the question, that is the slightly harder version. Okay, where what happens if now I increase the number to become 4x squared minus 25, right? So in this case, I will still put 4x squared over here and the number 25 over here. But still, that you notice there is no x term, right? So it's 0x. So in this case, I'll write this as 4x squared minus plus 0x minus 25. I still need to make sure my numbers are somewhat the same. So I'm going to look at what times what can give me 4x squared. And the numbers must be the same numbers. So that will leave us with 2x times 2x. And what times what can give me the number 25? 5 times 5 can give me 25. What do we fill in for this box? This is 2x times 5. So this one will be 10x. This box will be 5 times 2x. So this will also be 10x. And remember, I want them to add up to become 0. So 10x and 10x to become 0x. 1 plus, 1 minus. So I just put 1 plus, the other one a negative. Okay, and we'll have our two brackets. The first answer will be 2x plus 5. Second answer, 2x minus 5. Okay, so this one will be the answer. Alright, so I've come to the end of the video. So these are the few main skills that you will need for factorization of quadratic equation. I'll see you for the next lesson. Goodbye.